Hey everybody. Sorry I can't be there today. I got called to jury duty, so hopefully it's just a one-day thing. In the meantime, we are still going to go ahead with notes. Alright, so today we're starting chapter 1, dealing with linear equations. Hopefully this is very easy for us. Okay, so as we begin, one thing we have to keep in mind is when we're solving equations, we think about the order of operations, all right, but backwards. So let's just kind of zoom in up here and remind ourselves about those order of operations. Okay, so first, P stands for parentheses. What does E stand for? Well, we've already talked about this. That's our exponents. So you take care of those guys first. Then we've got multiply and divide. Those guys go hand in hand. And then we've got add and subtract. Okay, so those are our order of operations. You guys are pretty familiar with those at this point in the game. So now let's just go and quickly solve some equations, okay? Linear equations. So let's move on down to example 1. All right, I want you to solve and show all steps. So let's take a look at number 1a. 3 times the quantity 2x minus 4 equals 7 minus the quantity x plus 5. So let's work on each side of the equation first before we start crossing that equal sign. So you guys are good to go. Let's go ahead and distribute. All right, so we're going to have 6x minus 12 equals, now here we've got a minus a quantity, so we do have to distribute that to both terms inside of those parentheses. So we're going to have 7 minus x minus 5. Okay, cleaning up that right side, the left side still stays 6x minus 12, and the right side is going to now be 2 minus x, gathering those like terms. Okay, so now if we add x to both sides, add 12 to both sides, we are going to have 7x equals 14, and dividing by 7 we get x to be 2. Okay, so hopefully that's pretty straightforward for us at this point. Okay, so go ahead and try example B now. Okay, distributing, gathering like terms on each side first before crossing over that equal sign. Okay, so 5 times the quantity, 3x minus 2, minus 7 times the quantity, x minus 4, equals 4x plus 18. Okay, so we go ahead, we do our distributing. That's going to give us 15x. 5 times negative 2 is minus 10. Distributing the negative 7, so it's going to put us at negative 7x plus 28. And there's nothing on the right side to change, so we'll keep it 4x plus 18. Okay, gathering all of the like terms, 15x and negative 7x, we're going to have a total of 8x. Negative 10 plus 28 gives us a positive 18 equals 4x plus 18. Okay, so getting our x's on one side, our constants on the other, I'll subtract 4x, and I will subtract 18 from both sides. So that should put us at 4x equals 0. All right, how do we get x by itself? Divide both sides by 4, and we get x equals 0 over 4. Well, 0 over 4 is simply x equals 0. Okay, and there's our final answer. All right, so hopefully those ones we feel very comfortable with and can do those quickly. All right, example 2 here, now we're going to solve equations with fractions, and I still want you to show all steps. Okay, so first thing I want you to do is eliminate all the denominators. So you might hear me say this an awful lot to make things easier. I sometimes call it killing the denominators. All right, get rid of them. We are much more comfortable when we don't have fractions. Okay, so eliminate the denominators, kill the denominators. So let's take a look at what I mean here. Okay, so we'll zoom in on A. All right, 2/3 x plus 10 minus x over 5 equals 36 over 5. So the first thing I'm going to look at are the denominators, 3, 5, 5. And similarly to what we did in chapter P, we talked about the LCD, the least common denominator. Okay, so think about the first number that 3 and 5 go into. Okay, that they both go into evenly, and you should recognize that the first number they both go into evenly is 15. So what we're going to do is we are going to multiply every term by 15. Okay, and if we do this correctly, if we use the correct LCD, our denominators should go away. Okay, so here we go. 2/3 times 15. Well, I take 15, divide it by 3, so that's going to give us 5. 5 times 2 gives us 10. So we have 10x plus 10 times 15, that's going to be 150, minus x over 5. Well, 15 divided by 5 is 3. 3 times x is 3x. Equals, all right, 36/5 times 15. So 15 divided by 5 is 3. 3 times 36 is 108. All right, now it's a much cleaner equation. You guys are very comfortable with these types of equations. Let's go ahead and solve the rest of this pretty quickly. So gathering the like terms on the left side, 10x and negative 3x, it's going to give us 7x plus 150 equals 108. Subtracting 150 from both sides, that's going to be 7x is equal to negative 42. And then dividing by 7, we get x to be negative 6. Okay? So it is a lot nicer to eliminate those variables by multiplying by that LCD, or not variables, sorry, the denominators. Okay, so kill the denominators. Let's take a look at B. B's a similar type problem. Okay, so we have 2x plus 4 all over 3 plus x over 2 equals 1/4 times x minus 7/3. So the first thing we want to identify is what is the LCD of those denominators. Okay, 3, 2, 4, and 3. Okay, so we're really looking at 3, 2, and 4. What's the first number that all three of those numbers go into evenly? And hopefully you recognize that it is 12. Okay, so we are going to multiply every term by 12. All right, so when we multiply 2x plus 4 over 3 times 12, I take 12, I divide by 3. 12 divided by 3 is 4. So we have 4 times the quantity 2x plus 4. Plus, now when we take x over 2 and multiply it by 12, 12 divided by 2 is 6. 6 times x is 6x. Equals, now let's do the next one, 1/4 x times 12. 12 divided by 4 is 3. 3 times 1x is just going to be 3x. Okay, and then finally, that's going to be a minus. And we have 7/3 times 12. 12 divided by 3 is 4. 4 times 7 is 28. But that's a minus 28. Watch that sign. So now, again, this is a much cleaner equation to solve. Let's go ahead, gather the like terms, do any distributing. So we'll distribute that 4 leaving us with 8x plus 16 plus 6x equals 3x minus 28. All right, so still gathering the like terms on the left side, 8x plus 6x, we've got 14x plus 16 equals 3x minus 28. Subtracting the 3x from both sides, we're going to have 11x on the left. Subtracting the 16, we're going to have minus 42 on the right. Sorry, minus 44. So minus 44. And now dividing both sides by 11, we get x is equal to negative 4. So I find this to be a lot simpler than trying to get common denominators throughout and gathering like terms with fractions still in them. Okay, so I like to kill the denominators, make it easier on ourselves. All right? Okay, so let's go on to the next few examples and see what's in store. All right, so this third example, we're going to solve equations with special solutions. So we're going to show all steps. So really nothing new than the first couple of examples. It's just our solutions might look a little different. All right, so let's go ahead and zoom in on this first one here. Negative 2 times the quantity x plus 4 plus 3x equals x minus 8. So as you guys are very good at, let's go ahead and distribute that negative 2, gather our like terms. So negative 2 times x, negative 2x, negative 2 times 4, minus 8, plus 3x equals x minus 8. All right, so gathering the like terms on the left side, we are going to have x minus 8 equals x minus 8. Getting the x's on one side, they cancel out. Okay, so if I subtract x from both sides, those go away, and we are left with negative 8 equals negative 8. So what does that mean? The variables are gone. So I look at what's left. Negative 8 equals negative 8. Is that true or is that false? Well, hopefully you recognize, hey, negative 8 does equal negative 8. It's a true statement. So if it's a true statement, what does that mean our answer is? Okay, so our answer is no matter what I plug in for x, I'm always going to get a true statement. So it's infinitely many solutions. All right. When you get a true statement like that, you get infinitely many solutions when your variables go away. Okay, so again, this is review. You should recognize that, but a quick refresher. All right, let's move on to part B. 2 times the quantity x plus 4 equals negative 8 plus 2x. So again, let's start by distributing. So we have 2x plus 8 equals negative 8 plus 2x. Getting our x's on one side, you should recognize that 2x and 2x cancel. So we are just left with 8 equals negative 8. All right. Now, is that a true statement? No. Positive 8 does not equal negative 8. It never will. So that's false. Okay, those do not equal one another. So if it's a false statement, what is our solution? Well, no solution. No matter what value I plug in for x, I will never get a true answer. So our answer is no solution. Okay, so recognize the difference between those special solutions. Okay? All right, so our final goal is going to be solving equations for a certain variable. All right, you guys did this last year, but sometimes we struggle with these types of equations, okay, because there aren't necessarily numbers. So let's go ahead and zoom in at part A, solve for R. Okay, so identify what variable we want by itself. So we want R by itself. So sometimes it helps to circle it, draw attention to it. That's what we want by itself. Okay? So, in this part, there's kind of two ways we could go about solving. Okay? One way is to distribute the p to both of those terms. Okay? So when we do that, we get a is equal to p plus p times r times t. All right? So again, we want r by itself, right? So think about order of operations. So the first thing we're going to do here is let's get rid of this lone p. All right, so let's subtract p from both sides. So when we do that, we will have a minus p is equal to p times r times t. Again, we want r by itself. So how can we get r by itself? We are going to divide everything by pt. Divide by pt. All right, so when we do that, we get our final answer of a minus p all over p times t is equal to r. And r is all by itself. Okay? So there's one method to do it. All right, the other method that we can do, and I'll write it down here, is initially what we can do is divide everything by p. Okay, so if we divide both sides by p, we would have a over p is equal to 1 plus r times t. Okay, so now if we're focusing on this aspect, we still want to get r by itself. So the first thing we can do is subtract this 1. So when we do that, we will have a over p minus 1 is equal to r times t. So we still don't have r completely by itself, but the next step would be is let's divide everything by t. Okay, now this part is a little tricky. All right, so we're taking a fraction and we are dividing by something, right? Well, remember, let's do a little side note. If we had a over p divided by, that's like saying t over 1. Okay, remember, dividing by a fraction is like multiplying by the reciprocal. So this is a over p times the reciprocal of t over 1. So that's going to be 1 divided by t. And now we multiply straight across and we get a over p times t. So that's kind of the tricky part if we go about it this way. So when we clean everything up, our final answer is going to be a over p times t minus 1 over t is equal to r. Okay? So I think the first way in this sense was a little easier, but you can do it either way that you're comfortable with. And yes, those are the same answer. Okay? All right, let's take a look at the last one here. Part B. We want to solve for x. Okay? We've got 1 over a minus 1 over x is equal to 1 over x minus 1 over b. All right. So what we should notice is the variables are all in the denominators. But when we're solving, we need them in the numerators. Okay? Well, how can we get rid of fractions? What did we do before? We killed the denominators, right? So let's kill the denominators here. So we need to figure out the LCD. Okay? So the LCD between a, x, and b. So our LCD is simply a, x, b. And we're going to multiply everything by that. A, x, b. Okay? So when we multiply 1 over a times AXB. The A's cancel. Those, now it becomes X times B minus, when we multiply 1 over X times AXB, the X's cancel, leaving us with AB. Okay, we've got 1 over X times that again, so the X's cancel, leaving us with AB minus, when we multiply 1 over B times AXB, the B's cancel, leaving us with A times X. Okay, now what we need to do here is get the X's all on one side. So I'm going to add AX to both sides. Okay, and at the same time I'm going to add AB to both sides. All right, so it's going to look like this. Add AX, and so, add AB, add AB. So what this will now look like is AX plus XB is equal to 2AB. All right? Now I need X by itself. X isn't by itself here. Okay, but what we should notice is both of these terms have an X in them. So if we factor out the X, we are going to be left with A plus B, and now we're close. Okay, how do we get X all by itself? Now we are going to divide both sides by the quantity A plus B. So we'll have X is equal to 2AB all over A plus B. And now we've got X by itself. Okay? All right, so most of it was a refresher. Okay? Hopefully we understand everything and we don't have any questions, but if you do, I want you to work together, ask each other. Your homework is day 1. The chapter 1 assignment sheet is on our Schoology page under chapter 1. Make sure you go ahead and get that taken care of, finish that homework, and hopefully I see you guys tomorrow. Okay? Have a good one. Bye-bye.